And we are live on YouTube. Hello, everyone. We are back to our 32, the number 32 of the Everyone Can Contribute Cafe. And today we are looking into continuous profiling with polar signals. And I'm super happy that Frederick and Matthias said they would join us today for a bit of like introduction, some live demos, some trying new things, learning how monitoring, observability, and instrumentation and everything around works. And without further ado, I would like to hand over to Frederick and say, hey, maybe you can tell us a little bit about your story.
Yeah, absolutely. First of all, thank you for having us. So I guess to start out with, let's talk a little bit about like what continuous profiling is, and maybe a little bit also about like what led us to today, right? Like we founded a company around this, so clearly we believe that there's something bigger here, and how we got to this. So Matthias and I actually we met through kind of the Prometheus community. Yeah, so I'm basically over the last 5-6 years, I've worked on basically everything in the intersection of like Prometheus and Kubernetes. And in kind of late 2018, I read this paper by Google where they essentially described how they used profiling techniques, more specifically how they continuously profiled all of their kind of infrastructure to kind of cut down on resources consistently every quarter, right? And that was intriguing for multiple reasons, right? One, like I already knew how to kind of deal with data over time, right? That's exactly what we've been doing with Prometheus for a number of years. And then the second was I kind of loved the idea of this because I would have loved to have had that tool while I was working on Prometheus, right? And so kind of working on a prototype in kind of evenings in my free time, and I got super lucky and got to present this in a keynote at KubeCon, actually. I did this together with Tom Wilkie, where we essentially talked about kind of the future of observability. This was at KubeCon Barcelona. And kind of my part was that I thought that continuous profiling was going to be kind of the, if we go by that, by those terms, the fourth pillar of observability, right? And more broadly, I think we're going to see much more kind of getting rid of that terminology of like the 3 pillars of observability, right? I think it was probably useful as a framework to get started in the community, just to give people an idea of these are some things that are useful. But I think in a way it's also trapped us to think these are the things that we need, and we understand our production systems. And kind of the thesis was continuous profiling is one of those things that also allows us to really deeply understand the operational aspects of our applications. And we thought that there's a future to this, right? So that's kind of the backstory. And yeah, as I said, Matthias and I met through the Prometheus community. And actually, I initially hired Matthias into my team at Red Hat, and then after I kind of left Red Hat to found Polar Signals, Matthias kind of approached me and said, "Hey, this is kind of cool." So yeah, that's how we're here. So Polar Signals was founded about 6 months ago. In early February, we launched our private beta. So right now it's kind of an invite-only system, just so we can kind of work really closely with a couple of people so that we can figure out what is the most useful thing that people want from a product like this. And eventually, the idea is that we'll obviously GA this so that anybody can make use of this. So yeah, that's kind of very, very high level, right? Are there maybe any questions already in the room at this point that we can answer. Okay, I guess then I think the next thing that is always useful and cool to talk about is kind of what is continuous profiling actually, right? And how does it work? So continuous profiling, almost like the word says, right, is kind of the act of always taking profiles. So like maybe you know the situation of you have a memory leak in your system, and you only realize that there's a memory leak after the fact, right? Maybe when your application has been killed already, and you kind of never have the profile at the right time. So this is one of the use cases where continuous profiling can be super useful. It's very similar to any other observability data. You never know when you're going to need the data, so you just always capture it. So this is for memory, for example. And then for CPU, for example, the way it works is that essentially we look at the stack traces, let's say 100 times a second, and that way from that we can infer how much time is being spent statistically in certain functions in of your code. And the cool thing about continuous profiling, or really any type of profiling, is that because we have these stack traces, we can tell you down to the line number what about your program is actually using the most CPU, the most memory, etc. And because we're using these sampling profiling techniques, so as I said, looking at the stack traces like 100 times per second, it's actually really low overhead to do this, which is why exactly continuous profiling is made possible with sampling profilers. That way we can truly always have it running for everything in our infrastructure. Any questions on that point?
I read your blog post, which was published, I think, yesterday on Monday. And I think profiling or application performance profiling has been there for quite a long time. So like this is now the next level of profiling probably, right?
Right. So the way that we kind of think about it is that because we're now doing it always, before it was like profiling has always been a tool in the developer's toolbox, right? But it was more of an kind of on-demand type of thing, right? Like we profiled when we needed to profile, as opposed to always having this data. You can think of it as a similar thing to like going from like Nagios checks, where we do individual checks to see if something's doing the right thing at this moment in time, versus time series data, right? Where we always collect it over time and can kind of observe the state changes over time. And it's a really similar kind of shift with continuous profiling. All right.
Is it kind of like a prediction when the OM kill will happen, or?
No, so we actually just literally every 10 seconds take a profile. So it's not predictive or anything like that. It's just because we always take these profiles at a certain interval, we just will have the right profile at the right moment in time, at least within 10 seconds, right? Most of the time, memory leaks don't happen within less than that. Or if they do, then you probably noticed while rolling out already.
Thanks.
Yeah, but very good question. I suppose the next thing we could talk about is kind of compatibility, right? So the very first thing that we thought of when we were developing the open source project was what kind of data format are we going to use for this? And we, especially coming from the Prometheus world, we felt pretty strongly that the standard kind of needs to be an open standard, right? And the thing that we felt was the most developed standard out there is pprof. So this is a standard that Google developed, and it's essentially a very compact representation of the stack traces and the samples belonging to those stack traces, and kind of metadata about the functions, about the binaries that the stack traces originated from, etc. So that's basically why this is really cool, is that because it's an open standard, we actually didn't even have to write all of the client libraries for this. Like, there are already client libraries for Rust. There's a pre-prof integration directly in the Go runtime. There's Node.js. There's basically every runtime out there already has some sort of pre-prof compatible profiler. And even if not, the format is fairly simple, so it's fairly simple to implement these for each language, so that we have integration for all languages. We support multiple models of obtaining the data. In the Go world, for example, it's very typical that you have the pprof endpoints on your HTTP servers. So we allow scraping this data in a very similar model as Prometheus. As a matter of fact, we actually reused kind of the service discovery from Prometheus. We've had multiple users just drop our Polar Signals agent into their cluster and could automatically scrape their entire infrastructure because they already had pprof endpoints and their infrastructure is written in Go. So that's kind of the best case scenario, right? But we also have the ability to push this data. So if you want to, for example, with Go or with Node.js, for example, you can every 10 seconds push this data to Polar Signals if you prefer that model. So we don't really take an opinion here. Whatever fits your use case best, you can do. Any questions? Okay.
Yeah, mostly I have a question regarding the profiling, and then coming a little bit, probably I will go a little bit back, because I come also to the point when you say that profiling is overhead mostly. So a lot of applications, or when you have intensive workload applications like number crunching applications, probably it could be the option to that the profiling also needs the CPU memory, of course. So execution times could get a bit longer. And currently, what we're trying to achieve, if I did this now correct, so that when we're doing continuous profiling, we don't need to take so much samples. So the profile is also a little bit smaller and the overhead gets reduced. So then the complexity of the storage profile shifts a little bit back to your product or to your solution, so that you're storing and analyzing those into another part instead of doing it directly on the application stack, right?
Yeah, absolutely. Like that's the idea of the sampling profilers. We take few samples so that we have low overhead, and we merge all of this data into aggregated forms on the storage side, exactly like you said. And that way we can have super low overhead when we grab the profiles, but we can still ultimately have the same kind of understanding as we did with a really high resolution profile taken out within a short amount of time.
Cool. Yeah. Thanks.
Very good question. I guess we can go over to show a very quick demo of the product if people are interested in that.
Yeah.
Okay.
Yes,
Do it.
please.
We are all here for the demo.
So, I mean, we have, user management and login and etc. But that's not the thing why we're here, what we're interested in. But we kind of organize everything in organizations and projects, much like you see in other cloud providers, etc. But the really interesting part is the way we query this data, right? So the way that you query it is very similar to Prometheus, actually. Surprise, surprise. Given our background, you kind of treat the type of profile sort of like the metric name in Prometheus, and we created the query browser so that you can discover these things nicely. So here, for example, this is our actual production infrastructure. We can query all of our heap profiles, for example. And when we, what we see here is kind of the cumulative data of the samples that are within these profiles. So whenever we send a heap profile, for example, here we can see this is our Jaeger tracing pod that we have deployed in our Kubernetes cluster. Every time we send one of the profiles taken from Jaeger, on Polar Signals side, we add all of these up and actually write it to a metrics storage. So what we've actually just queried is actually a metric storage. So far, we haven't actually queried any profiling data. But we did this so that you can have this kind of better view of the data rather than just seeing samples over time. That's what we had initially. But what we found was that everyone who used our product first went through resource metrics with Prometheus, for example, to find the right timestamp to then query Polar Signals. And so it was kind of natural for us to have this integration where we allow you to query this in form of metrics. And then you can select any of these points over time, and you can view the profiles. So we have various visualizations, the things that you're probably already familiar with from the Go tool chain. So here's the call graph, where we essentially can see the critical path, but we have also fitting to our branding icicle graphs. It was funny when I first read this. I actually learned that these are called icicle graphs after we came up with the name. So it was kind of a happy little accident. That Brendan Gregg actually calls these kind of upside down flame graphs, icicle graphs. Just a quick anecdote on the side. But yeah, we have all of these various visualizations. And one other cool thing that I want to show real quick is what you can do is you can create these shares, and this will open a separate tab, which I'll switch to 1 second. And what this does essentially is it creates a publicly shareable link of this data. Whoops.
Yeah, so this was mostly done because what we found up until that point was that a lot of people usually just screenshotted pprof profiles, right? And then just pasted them into GitHub issues, and you couldn't really like interact with these profiles. And hence we kind of like set out to create this little service where you can just like share it, and yeah, then not only view it, but you can kind of like modify it and zoom in, zoom out, and yeah, kind of like use it as you would locally as well. So that's kind of the idea behind this.
Exactly, kind of so that you can collaborate with your team, right? If you've worked with profiling in the open source world, for example, what people always do is they take screenshots and paste the screenshots onto pull requests. And the kind of annoying part about that is, as a maintainer of open source projects, you actually want to explore this data, right? But you only get these static screenshots. And so we decided it would be cool to host this free service for people. And so anybody can go to share.polarsignals.com and upload any pprof compatible profile and kind of share it with their team on a GitHub pull request, etc. Just kind of wanted to show that real quick. So let me go back to where we were before. So this is where we left off. One cool thing that I wanted to show was let's compare multiple profiles in time. And why this is particularly useful is we're essentially able, what we've just done is we've taken a profile of a lower memory profile with and comparing it with a higher memory profile, right, at two different points in time. And why this is really cool is all of a sudden we're able to kind of cut out all the noise that was there before, and we can truly see the actual difference between these two profiles. And when we have a memory leak, for example, we can truly tell what grew in memory, and that way we're really quickly able to say this is exactly the piece of code that is leaking memory. And we can do this with all sorts of queries. So another thing that you could do, for example, let's do this, for example, you can actually merge this data into one report, right? So as you can see, I queried, okay, I only queried over 3 minutes, but this ultimately was samples of 220 seconds, right? But the idea is you could take these merge queries now and compare those as well. And the reason why this is useful is now we can actually merge all of these reports, right, and compare different versions of software. So we can now answer like these kinds of questions that were really difficult to answer before, like I rolled out a new change and there was a performance hit. Tell me why, right? We can actually have this down to the line number, what kind of changed in performance. We can say kind of vice versa, right? I did a performance improvement. Did it actually have the effect that I wanted it to have? The kind of merging of data as well as comparing different queries with each other is really powerful for this. Yeah, I think that's mostly it in terms of kind of the feature set. Or Matthias, can you think of anything? I mean, we can query data of up to 14 days. Let's see, here we go. But yeah, that's just more in terms of like how much retention we have right now. But yeah.
I think you can quickly show how to filter just for one series, maybe. So kind of like when you usually use Prometheus, right? You search for the up metric, for example, and then you drill down into a more specific one. So all of that is totally possible as well. And then if you kind of found the more specific profiling time series you're looking for, you can then merge these together as well. So like all of the filtering that you know from Prometheus, given the fact that it is PromQL, for the most part, it really comes with the same feature set in that sense. Yeah. Yeah.
And we also wrote kind of a little bit of a like autocomplete feature similar to the one that that Prometheus introduced. Yeah. And as you saw, like you can do various interactions. You can click on labels and it'll autocomplete, etc. So that's just to kind of round up the experience a little bit more. Any questions or anything that we should do that you want to see?
I have a question about, because I'm not 100% aware of the Heap protocol. So when you show the call stack, do you have a start point? So is it one call and it's the whole tree? Because there are hundreds of calls, of course. So do I have to add to my application something like a start point and an end point to map it to some object or something like that?
So because of how sampling profilers work, the only thing that we have is stack traces, right? And we know how often we've seen a particular stack trace. So if this is in particular when we look at the CPU profiles. So if we look at this profile, for example, the leaves that you see here, these are essentially the entire stack traces that we see. And depending on how often we've actually observed those stack traces, that's kind of what drives up the particular nodes in this, right? Each of the nodes in here is kind of part of the stack traces.
Okay.
Yeah, and that way, because we're observing the code at runtime kind of 100 times per second, we can infer that if we've seen a particular stack trace twice, then that's 2/100ths of a second, right? And it's essentially statistics at this point.
Okay, so it's a total snapshot at the time.
Yeah, basically. The point of sampling profiles, though, is that we don't take an actual trace, right? We only look at it 100 times per second.
Okay, thank you.
Yeah.
If I have my current monitoring system with metrics and Prometheus, probably, is there a way to correlate the data from the profiling or from polar signals with like metrics, logs, and traces? So like that I have a global view on things and can like say, hey, this change or this potential problem detected by the profiler is influenced by a system outage or something else.
Yeah, so actually, let me show you what's going on behind the scenes here, because it'll look familiar. So actually, this graph that you're seeing here is truly a Prometheus query that's happening. And so we're kind of doing what you just said already. So the graphs that you're seeing are actually produced by a Thanos backend, which we push metric samples to. And these metric samples we calculate by kind of summing all the values that we see, summing up all the values that we see in a profile. So let's see. When we click on this profile, for example, we see kind of value is somewhere around 15 gigabytes, right? And we can look at this. It also says here, sorry, this was CPU. So maybe let's do Heap. That'll be a bit easier. So we click somewhere here, and it says 1.4 gigabytes, right? So essentially, we add up everything that we see in this profile and write a metric sample to our metrics backend here. And so because we're labeling this data consistently, right, we're actually doing this jump already from metrics data to profiling data. And so this is something that we want to take further. And actually, someone in the community has already built a Grafana plugin for our open source project. So that's really easy to integrate with polar signals now as well, so that you could actually use Grafana annotations to do this jump as well if you wanted to.
Thanks. So I could see polar signals then as an add-on similar to like linking traces to metrics somehow, probably. So we have the 4 pillars of observability now again, with like metrics, logs, traces, and profiles. It's interesting. If we can like convince everyone to do the same, probably creating a new standard.
Yeah, I mean that's definitely super interesting. As I said, we really strongly believe in the Prof Standard. We think that it's like the kind of perfect mix of expressiveness of the data, but also really optimized for this type of data. I think where we're maybe kind of missing a standard still is kind of how we're actually representing this over time, right? And we're actually representing it identical to Prometheus time series. As a matter of fact, in our storage, we actually call these profile series, and they're labeled exactly like metrics data in Prometheus. So I think this is would be super cool if we could standardize it up to this point. But even if we can only, as a community, agree on the Prof standard, that's already would be really amazing.
So I have a few questions, and one of them is kind of quite closely related to that. And do you think that there's an open telemetry kind of angle on this, where especially with Prof, like this becomes part of OTel and something that's getting sent to wherever? Is that something you're thinking about?
So we've actually had this very conversation with other like continuous profiling providers, and there's definitely interest for something like this. The last time we spoke, we were like, all of the companies and projects out there are still pretty young, right? So we kind of concluded with, let's kind of let the standards that we're all using kind of sink in and see how they hold up over the next year or so, and then kind of come back and see, like, these are the things that we've learned over the last year. This is how we can standardize on something. There's definitely lots of interest in this, so I expect eventually we'll be working with the community on that. Yeah.
Okay. Yeah, we've got a little library called LabKit that we drop into all of our Ruby and our Go binaries. And at the moment, for the Go ones, it actually sends, because we're running on GCP for GitLab.com, it sends our profiles to Cloud Profiler. But unfortunately, that's only the Go binaries. But we do find it to be super useful in certain circumstances, particularly when you're looking at performance diagnostics and memory leaks, and it's a super useful tool. So I think this is great. The question I had was, one of the things that the first thing that we really miss with Cloud Profilers is anything other than Go, in particular Ruby. But then the other part is around a lot of the profiling that we do is actually at the system level. So if you've got something like a Gitly server, you have all these Git processes that are spinning up and shutting down. And really what you're trying to do is figure out what's going on at the system level. Is that something you're thinking about?
Yeah, that's absolutely something that we're thinking about. And actually, I guess I can tease a little bit without saying too much. Where there was actually something that we had hoped that we would get ready for today. Unfortunately, it's not quite ready, but it kind of goes into that direction where we essentially are automating profiling and doing like whole system profiling and stuff like that. Unfortunately, Ruby support we don't have today, but there's precedence of Ruby profilers, so it's only a matter of kind of putting it into the right format.
Fantastic, thanks.
And as I said, because all of this is Prof, it's an open standard, right? Like, you're not even buying into some proprietary system. Like, there should be a Prof library for Ruby anyways, whether you're using polar signals or not. So that's kind of how we think about open standards anyways.
Yeah, that's really awesome.
What we already published like a month ago is a little tool called Professor, where we essentially take perf profiles and convert them to Prof, which is actually done by another little tool that was already out there, but we kind of bundled it up and made it work with our continuous profiling. So you can essentially hook it up to a Comprof or even send it to our cloud. So yeah, there are some things, but yeah, we can definitely go further. That's for sure.
Yeah, Professor is actually, go ahead.
And I just looked up there are some repositories out there where they already hacked on Ruby and Prof stuff. So if we can together drive that would be amazing for sure.
Yeah.
Awesome.
Yeah, it's great that you mentioned Professor. That's actually something, if you have kind of native binaries today, that's something that would already work down to the kind of system level. It even like jumps into like shared libraries and stuff like that. The thing that's a little bit annoying about perf profiles is that you need the debug symbols around, right? However, there have been kind of some cool projects in the community by particularly by Sentry, because they essentially have the same kind of problem set, right? Like they want to symbolize native stack traces, but they actually want it for like core dumps and stuff like that. So not really profiling data, but it happens to be a similar problem space. And so they actually build kind of what are called symbol servers, where you can have kind of a federated model of let's say the Sentry or the polar signals symbol server can reach out to symbol servers from Debian, from Fedora, from Microsoft, and will kind of request the debug symbols at runtime. And that way we can actually symbolize all of these stack traces after the fact. And as a matter of fact, that part landed just yesterday in our open source project. And it's also going to be something that we'll be integrating into polar signals pretty soon, so that we can kind of take these native stack traces and not always send all of the kind of debug symbols with every single pprof profile that we send to polar signals, but only upload the debug symbols once and then only send the native stack traces if that's possible. That way we're also reducing what's stored in the storage and what goes over the wire, right? I think Matthias shared all the links for Professor.
Thank you.
Thanks.
Any other questions?
Is it like how you would use polar signals when you're on-prem and don't want to use a cloud offering? Can you use it, or?
So today we only offer the service. We may offer kind of on-prem in the future. We definitely have had very large enterprises request it, and it's tempting, but at the same time, kind of innovating in a service is much easier, right? So it's especially for a very young company, a very small company like us, it would be extremely risky to go through kind of an on-prem sales cycle right now that takes like a year or 2 years, right? That then ends up failing, and we kind of neglect the service, which is something that we can more iteratively build. So I'm not going to say never, but for the time being, we'll be offering the service only. That said, if you're really interested, there is the open source project that you can try and see how far you get with that as well.
Okay, thank you.
I actually have the new comparison view up and running, so we can take a look. And I was just waiting for some data to come in the last couple of minutes. So yeah, I can share that if people are interested.
Absolutely, go ahead.
Let me. All right, that should. Now it shared my entire screen. Why is it resizing things every time? Where did Zoom go? Okay, so you should be able to see like a 4:3 screen roughly, right?
Yes, we can see that.
Yes.
Right. Yeah. So from what we've seen earlier, there was the capability of comparing, and this is just like a local cluster right now. And what we're looking at is actually Prometheus running on my machine as well. So it's just like sitting there, and I just ran some queries as well, as you can see. So we're looking at the heap profiles of that Prometheus running on localhost 9090 on my machine, and then just every few seconds scrape some profiles from that. So yeah, like in the past, or still right now, but hopefully I can get this out soon. You had to select one and then kind of manually select the other one. But given the fact that we have metrics for both sides, the idea was to kind of split so that you can have select the query for the, or like the profile on the left-hand side, and then compare it against something on the right-hand side. And yeah, the UI is slightly broken, so I need to do a few bug fixes before this goes into production. But yeah, like as you can see, we can get like take like a low data point and then a high one, and then we get kind of the same diff, like the same comparison view, or like the same diff of a profile. But it's probably a lot better to understand what we're actually looking at, given that we have these points here. And yeah, we can like clearly see that just by me running a few things, you actually had quite a difference here in memory. So yeah, like taking this a bit further, you can now just like click around. You can then compare the right one with this left one, where the memory is slightly higher. You can just like, yeah, slice and dice it as you wish. That's kind of the idea behind all of this. Yeah, basically make the most of like these observability pillars that we have, and given the fact that, as I said, we have metrics as well, we try to make the most out of this. So that should be coming soon. And yeah, hopefully that will even make it more accessible to compare profiles. Any questions? Happy to also walk you through any of this. But hopefully it's quite intuitive, right?
Yeah, I wanted to point out, so the part of the reason why we're doing this is because of obviously feedback that we've gotten from our users. And one thing that's been super cool is a bunch of people who we've given access to the private beta have opened kind of random across the board issues on usability, on functionality, etc. On kind of a public repo that we have, that's polarsignals/issues. And this was one of the examples where one of our early users was saying this is kind of not quite intuitive enough, and we use the product on kind of a daily basis as well, right? So we agreed, and so this is why we're working on this. I guess that I wanted to give a shout out to if you're interested in trying this out, let us know. You can either write to us directly, or you can just go to our website and request beta access. And yeah, so we're super happy to kind of listen to all of your feedback. Obviously, we're most interested in creating the most useful product we can. Yeah. So that's polarsignals, github.com/polarsignals/issues.
I will link it in the blog post and also on Twitter. Thanks. I was wondering about the like midterm roadmap. So what is like at the top of your head, like in 1 year time, in 3 years time? Where do you see yourself?
Yeah, that's a great question. 3 years time is probably too far out to tell, but the most immediate things are kind of figuring out the usage patterns even more than we already have, right? We've kind of understood what people want to use the merge functionality for, what people want to use the diff functionality for, and even individual profiles, right? So we've kind of figured that out by now by working with our early customers. And now we're kind of optimizing the product for those access patterns. And I imagine that'll happen over the next 3 to 6 months. And that kind of goes through the entire stack that as you just saw, is about user experience, but it's also about the storage as well as the kind of query language and query patterns and query engine, so that we kind of optimize everything from top to bottom, that the storage is very efficient, that the querying is very efficient, and that it actually kind of gives you really useful data and visualizations, right? So that's probably what we'll be spending most of this year on. And again, this is always going to be very dependent on the kind of user feedback that we get. We think that some of the things that we'll be developing are kind of recommendation engines, so that we can automatically see, hey, this is Go code. Typically, kind of what is it? Grow slice is a very CPU intensive thing. If you just pre-allocate a slice here with this size, you'll save this much CPU time or something like that, right? These kinds of things would allow people to make these changes much faster, right? And ultimately create a better product, because that's what people want to use these kinds of products for, right? They want to make optimizations, and if we can make recommendations about good optimizations, then that's only helpful.
I have many ideas in my head right now. One of them is machine learning. The other one is like having public profiles being uploaded somewhere. So you have like a training model for machine learning later on, where you can like use the recommendation engine you're talking about and saying, hey, this is like, okay, this is Go, but for like the C++ or for the C development, you need to use a different pattern. And the more data you can like collect from the community or from your customers, the better the results will be. I'm just not sure if is there any privacy implication from continuous profiling. But yeah, just at the top of my head, I would love to see and build that.
Yeah, I think there are definitely some interesting things here. I want to say, I think the biggest impact we can probably have at first is more of a kind of, let's call it static analysis rather than machine learning. I think we can already make a lot of really good recommendations just by kind of putting our expert knowledge into the recommendations, right? But also, I think there are cool things where we can understand the interactions of processes that are on the same node, for example, whether they're kind of trashing CPU caches or something like that, right? And we can recommend kind of Kubernetes pod anti-affinities to say these two processes should never be on the same node. They keep trashing each other's CPU caches or stuff like that. So recommendations can go various ways, right? That's what I'm trying to say.
Yeah, I think, and the next idea I had was like, when you share the profile as a URL, you also want to share maybe a preview image like a PNG or JPEG, which you can then embed in a pull request or merge request, so that when you do continuous profiling for the staging deployment, for instance, you have sort of review apps, but also like review profiling somehow, and you can immediately see that this commit poses a regression in the code, performance drops, and you never merge it to the main branch. And just to visualize it better, finding a way to like give back the data either as a PNG or as a JSON blob or whatever, so that GitLab, GitHub, whatever tool is used can create a table or create something useful. maybe in the first iteration, this can be done by just like querying the REST API of those tools and adding a comment to the pull to the merge request. And if you start with recommendations for code, maybe there is already an existing one, like I think source graph or something else, which you can like use so that all the tools out there can consume the same standard again and just show it. And you have like, just thinking out loud, in GitLab, you have like a suggestion for the code. And this is like coming from the continuous profiler, and you can just like review it in a merge request and say, hey, I like that. Do not auto merge everything, but I like that. And it's coming from continuous profiling because the thing is learning from the data it currently has.
Yeah. I mean, and there are kind of other cool kind of network effects, right? Just like what you said. Because we have the kind of data down to the line number, we could open your code directly in Gitpod or something like that, right? Or name another like IDE that's browser-based, right? Like code spaces or stuff like that. I think those are cool integration possibilities, yeah.
I think I've created work for you for the next three years then.
Yes. Yeah, we're definitely really excited about kind of the possibilities that this type of data gives you, especially because it's so high resolution, right? Down to the line number. And I think that's something that has kind of excited us from day one, that we have this possibility to tell you, go to your editor at this line number and you'll see why this is happening. I think that's really magical almost. I don't think there's really another observability signal that gives you that kind of tactical action, right? Like all the other things that we have, maybe log lines can be similar if you include the line where it was logged from, but like metrics or traces are much more higher level concepts, and they should be, right? I'm not saying that that's a bad thing. I'm just saying it's kind of magical that with profiling you get that.
Yeah, I think at least from my experience and like being a past open source maintainer myself, I was spending lots of time trying to understand the logging, the metrics, and the traces. Probably didn't have any traces back then, but still it was so much time being invested to totally understand the problem, because it works on my machine is not like the customer system works, and the distributed monitoring didn't really scale or was running out of memory. And if we would have been able to just use continuous profiling in a specific sense, I still have no idea how to use the parameters for perf and for all the different tools out there. It's known knowledge probably, but still it's so much to learn and so much to understand. You need an expert by your side. If we make it easier and also find ways to not bind it to the developer who created the code, but everyone can just act on like a suggestion saying, hey, if you add this slice, this is going faster. Or if you're using not shared pointers, but unique pointers in C++, there is a certain way of improving that. So I think this is like you're filling a gap of knowledge, probably what everyone tries to approach currently. Like you have sort of application performance monitoring ideas, but you need more than that, because you want to prevent that the problem is actually happening in production, but you don't know it yet. So sort of like a little bit of prediction, but I could, similar to Captain as a quality gate, I could also imagine that when you're doing continuous delivery, that you have sort of a continuous profiling quality gate, which prevents from deploying to production just because there's a potential problem with the performance. And this builds the bridge to the to SLO conf. The SLO is not matched because the login time into your SaaS application is 5 minutes. Like I told about GTA Online, which had an algorithm problem. This is something potentially which could be detected by that. Like building the picture even greater. Yeah, interesting times coming ahead. There are no solutions yet, but we're all building towards that. So this is super interesting.
Yeah.
I think I've generated work for Andrew as well.
You do that from time to time.
Yeah, I wish I could clone myself and also become an SRE. And yeah, but still, I might. Well, I totally should be checking out the beta. I was wondering, and I don't know if you have mentioned that before. How long are you planning to run the beta?
I don't think we have a set timeline on that. It's more of a question of like, at what point are we confident enough in the product that we can have whoever wants to, how many people ever want to kind of access the product, right? When we're at that point where we're comfortable with that, that's when we'll release it as a public product. Obviously, like as a business, there are other things that we need to consider, right? Like we need to figure out that kind of the margins are right for the business. We need to make sure that it scales. We need to have like things like billing, right? Like things that you don't want to think about as an engineer necessarily, but it's one of those things that is kind of crucial to building a business. Yeah.
Definitely. If you're thinking about the languages you currently like have in the private beta, is there a specific one where you need more data, or where we or the ones who are listening to the stream right now, where we can help you of like saying, hey, we have nothing around Rust. Is there something where we can like everyone can dive in and help contribute?
So it's funny that you mentioned Rust, because there's actually a Rust profiler for CPU, but there isn't for memory. I think the folks at PingCap started working on one, so but they didn't finish it, and I think the pull request is still up for grabs if anybody wants to finish that. So if there's a Rust expert out here listening, that would be a really amazing one to finish up. I think most of the other languages actually are pretty far advanced. I actually wasn't sure about the state of Ruby, so that's also a really cool one. We know of people using not the Python one, the Node.js one. Go, obviously, those are kind of the two most used ones with the people that we're working with right now. But obviously, a really big one for us is going to be Java as well. So if there are kind of Java experts out there who want to work on pprof compatible profilers, that would be awesome. Yeah, I think Rust and Java and Ruby, those are probably the ones that we have the least grasp on. So if there's someone who wants to create some profilers, we're more than happy to help out on like the format, right? The format is something that we're very deeply involved and invested in. So more than happy to help with that.
Thanks. I think I need more time. Are there any more questions from everyone now listening?
From my side anymore.
I think everyone has requested a private beta now, so you need to click approve.
Great, all of our metrics going up.
Hopefully. Yeah, then I would just say thanks for joining today. I would totally love to catch up, like in half a year or something, when you have something new to present, or maybe some more insights how your story went. And until then, we can like try everything async and provide feedback. I will summarize all the URLs and things we talked about today in a blog post.
Awesome.
Yeah, and I would just say thanks for listening. Thanks for tuning in. Next week, we will learn about Sneak and a little bit of container security, just as a teaser. And with that, I would just say bye-bye on YouTube.
Bye-bye.